Hi guys, here in this lecture we are going to discuss an important homogeneous catalyst, that is Wilkinson's catalyst. We have frequent questions from Wilkinson's catalyst in various competitive examinations of chemistry. That's why it is important to discuss about Wilkinson's catalyst. Okay, so Wilkinson's catalyst is a homogeneous catalyst and which is considered as Wilkinson's catalyst here the rhodium catalyst, where rhodium is coordinated with three triphenyl phosphines and one chlorine ligand in a square planar geometry. Okay, just take its complete structure here. Now, what is the major application of Wilkinson's catalyst? Wilkinson's catalyst hydrogenate unsaturated compounds like olefins and here we can say alkynes. Okay, alkenes and alkynes. I'm just taking one general example, one terminal alkene. In presence of Wilkinson's catalyst, hydrogenation takes place at room temperature with a suitable solvent. Here we can take that is benzene. Okay, and here is the product, that is saturated product is obtained. Okay, right. Here Wilkinson's catalyst has great importance because which can tolerate many functional groups on the substrate. So here the substrate may not contain simple unsaturation, that is alkene or alkyne functional group. It may contain so many functional groups on it. Okay, like keto functional group, ester functional groups, or carboxylic acid functional groups, nitrile functional groups, or ether functional groups. Okay, right. Whenever these functional groups are present along with unsaturation on particular substrate, Wilkinson's catalyst only affect unsaturation part of the substrate. That means it hydrogenate only unsaturation part of it and it doesn't affect any other functional group. Okay, that's why Wilkinson's catalyst has great importance and applications nowadays. Okay, right. Now here we need to look at important substrate selectivity with Wilkinson's catalyst. Okay, right. Whenever olefin is connected with functional groups like, okay, here we have taken nitrile electron withdrawing groups, then the rate of hydrogenation of the given olefin is high with Wilkinson's catalyst. Okay, whenever the alkyne and alkenes or with some functional groups or just polar groups like hydroxy groups, then alkyne is preferred over alkene for the hydrogenation with Wilkinson's catalyst. Okay, and also we can see some other functional groups like here phenyl group. Okay, just take it here phenyl and other order, that means here you are taking order of hydrogenation of different olefins. Okay, here just take ethyl group, right? And whenever we compare with olefins with high branch on it, that means terminal alkene with high other side branch, alkane branch, then there is no difference of rate of hydrogenation on this terminal high substituted olefin. Okay, right. Now, whenever we compare the simple olefin, that is terminal olefins and internal olefins, the terminal olefin is preferred to get hydrogenation with internal olefin with Wilkinson's catalyst. Okay, and cis olefins are preferred to get hydrogenation with Wilkinson's catalyst when we compare with trans olefins. Okay, and here isolated olefins are to get hydrogenation in compared with conjugated olefins. Okay, so just take all of these substrate selectivity of Wilkinson's catalyst. Okay, now we need to look at the mechanism, the general mechanism of Wilkinson's catalysis, and here just take the first step is the oxidative addition. Okay, oxidative addition of H2 onto rhodium of Wilkinson's catalyst followed by olefin insertion. Okay, so here, sorry, olefin interaction or coordination with rhodium metal. Third step is migratory insertion. Okay, migratory insertion of hydrogen, that means hydride migrate onto the olefin. So just remember that migratory insertion is the slow step and rate, that means rate determining step in Wilkinson's catalyst, and it is important for your competitive purpose. Okay, and next step is reductive elimination, and from that the product is, that means hydrogenated product is eliminated. Okay, right, and here so we have discussed that only the olefins which are substituted or hydrogenated with Wilkinson's catalyst. Then what about a simple olefin? Okay, so just consider a simple olefin, that is CH2 double bond CH2. Is it get hydrogenation with Wilkinson's catalyst? So here it doesn't, because we know that simple olefin is a strong pi acid. Okay, and there is no steric effect or steric factors, right? And another important point, just remember that whenever steric factors or steric repulsions increases on olefin, the rate of hydrogenation decreases. Okay, so here the simple olefin is a strong pi acid, and due to lack of steric factors or steric effect, it can interact with rhodium transition metal of Wilkinson's catalyst very strongly. So that's why the migration of hydrogen onto olefin and the cleavage of the product is not possible. That's why here the hydrogenation of simple olefin is not observed with Wilkinson's catalyst. Only substituted olefins and alkynes get hydrogenation with Wilkinson's catalyst. Okay, right, now just take an example here. So I'm just showing one example here. The substrate, that means having 6-membered ring with unsaturation in it. Okay, right, and this is a substrate. Whenever we apply Wilkinson's catalyst, then where the hydrogenation takes place, so substrate selectivity. Now just look at this unsaturation, which is tri-substituted unsaturation part of the given substrate, and here this is di-substituted unsaturation part of it. Okay, as we said, the Wilkinson's catalyst prefer to hydrogenate less substituted olefins to escape from the steric repulsions. Okay, so that's why here the product can be observed as like this. Okay, just take it. So the hydrogenation takes place here on di-substituted unsaturation part of the given substrate. Now just take another example, that is with two types of functional groups on it. Okay, two types of unsaturation parts on it. So here we have one cis substituted part or cis substituted olefin, and here we have trans substituted olefin. Whenever we apply Wilkinson's catalyst, as we said, here substrate selectivity, cis olefin prefer to get hydrogenation with Wilkinson's catalyst, so trans olefin is not going to affected by it. Okay, right, now just take the stereoselectivity of Wilkinson's catalyst. Right, here just take an example. So here we have taken carbonane with so that means CH2 olefin functional group. Okay, so here we have CH3. Now whenever we apply Wilkinson's catalyst, in general here we have two possible products. Okay, so one is so methyl group here, and here CH3, and other one is, just take it, CH3, CH3 and hydrogen. Okay, the first one is endo product and second one is exo product. Which is the major product? here. So simply the endo product is major product with high selectivity. So nearly 92% yield observed for this endo product when we compared with exo product. So here that means the change or the high productivity or high selectivity of endo product is steric factor. So whenever the Wilkinson's catalyst is going to interact with this unsaturation part of the given substrate, so whenever it is going to interact or coordinate with that unsaturation part of it, so here two possibilities are there. One is from this end and one is from this end. That means backside end. Okay, right. The rhodium interacts with that unsaturation part from that backside end. What happens? The steric repulsions or rises from that CH3 group. So that's why here the hydrogenation is not possible from that backside end and we cannot get the product from it. Okay, that means it is the minor product we can observe. Whenever the rhodium interacts this unsaturation part from the top face, okay, so in that condition the steric repulsions are less with this bridged methylene, that means CH2 group. That's why it is favorable attack and hydrogenation takes place from this side. So whenever hydrogenation takes place from top side, this CH2 with the incoming hydrogen, that is CH3, completely move back side to it, and here we have the hydrogen which comes from that hydrogenation and methyl group goes backside and we can call it as endo product. Okay, so this here we can see dash stereoselectivity of Wilkinson's catalyst. Okay, thank you very much, and if you are interested, just visit chemmasters.online website and get registration to get standard courses with online test series to get guaranteed success. Thank you very much.